Hi parents, we are doing multiplication now. We're going to be doing multiplication for the next few weeks, and then we're going to go into long division that also has multiplication in it. So let's practice some multiplication. Now, we're going to practice multiplication by doing a few different means of answering. The two biggest ones I want my students to learn is partial products and algorithm. To do partial products, you first just have 5 times 6, 5 times 80, and 5 times 100. Looks like this. 5 times 6 is 30. 5 times 80 is 400, and 5 times 1 is, or 5 times 100 is 500. And then you add it together. There's going to be two common mistakes that come along with doing partial products. First, sometimes students have a hard time thinking what 5 times 80 is in their head, but they'll be able to do 5 times 8. The second thing is sometimes they don't line up their partial products correctly. Like for example, they'll go like this. So they'll try to do this. 5 times 6 is 30, and 5 times 8 is 40. And then because it's 80, they'll add on a 0, and then suddenly they are not lined up. And when they go to add this, like 5 times 1 is 5, and then there's 2 zeros because it's actually 100. I've seen students go like this, and suddenly things are just not lined up, and everything's just all over the place. And so to prevent that, one trick that you can do is if your student's struggling with partial product, is just write them out separately like this. 6 times 5, 80 times 5, and 100 times 5. And just write above or to the side wherever. 6 times 5 is 30, 8 times 5 is 40, but it's really 10 more because it's 80, so add that 0. And then 100 times 5, or 5 times 1 is 5, and 2 place values, 2 zeros. So like that. And then you can just write it out. 400, see now when they see 400 all written down together, they can try to visualize where that looks like, lining up the ones. 500, make sure you line up the ones if you need to, write right to left like this. And make sure your student always focuses that the ones placement's lined up. If the ones placement's lined up, most of the others will most likely be lined up as well. Now, to solve, just add it all together, and voila, there you go. Algorithm is you're going to be adding into the next place value as you go. So 5 times 6 is 30. We put down our ones, which is 0, and we exchange 30 ones for 3 tens. So we do a plus 3 right here. 30 ones becomes 3 tens. 5 times 8 is 40, plus 3 is 43. Make sure they don't say 5 times 3. 5 times 8 is 40, plus 3 is 43. So we place down our ones, 3, and we have 40. So we're going to exchange 40 tens for 4 hundreds. 4 hundreds. Exchange 10 for a single in the next place value. 4 tens becomes 4 hundreds. Now, 5 times 1 is 500, or 5 times 1 is 5, plus 4 is 930. There we go. The last thing that we're going to be teaching students is how to write it out in expanded form. So it looks like this. Because 5 times 6 looks like this. 6 times 5, 80 times 5, and 100 times 5. Just like in partial products, you do 6 times 5, 80 times 5, and 100 times 5. And in the end, you add them all together. So expanded form looks like this. 100 times 5, and use parentheses because that's one step, plus 80 times 5, plus 6 times 5. Just like that. There you go. One thing that I've also taught my class as well is that 186 times 5, 180, or you know what, just to make it simple, let's do times 3. 186 times 3, 186 is the same as 100 plus 80 plus 6. That is our expanded form. Now, if you do times 3, it means we're repeating expanded form 3 times. Because it's times 3. Now, when they show their work, they don't need to do this, but this is a great way to explain it to your student. You have 3 6s added together. Multiplication is repeated addition. That means it is 6 times 3. It's the same as 6 plus 6 plus 6. Same thing with 80 times 3. Same thing as 100 times 3. And voila, you got expanded form. Now, here is the big question that even I once asked myself. Why? Why not just teach algorithm and move on? That's how I did it in 4th grade, actually. It's probably how you did it in 4th grade as well. Why are we doing all this other crazy stuff? Well, I'll give you 3 solid reasons why. I once thought the same way, but here's a good example. Without a deeper understanding of multiplication, problems like this where you find the missing digits is going to be next to impossible. Our goal is not to teach memorized steps. It is to teach multiplication. And if we're going to teach multiplication, they need a perfect understanding of multiplication. And that's the goal. We're not going to teach steps. We're going to teach how to multiply. Here's reason number 2. Because this is not too far into the future. It's only a couple years away. We have 256 times y. So y is a number we don't know, divided by 8 equals 160. Now, this is multiplication. 256 times y. Can you just do some algorithm? You cannot do an algorithm with 256 times y. You need to understand multiplication. That's not the form of an algorithm. The algorithm needs to be learned because it's the most efficient way to solve large multiplication problems. But not everything with multiplication means you solve. You are not solving y by doing multiplication. You're actually solving y by first doing division. And that is going to be a few years down the road for these guys. So, yeah, they need to understand that. And here's a third good reason why. They're going to be tested on it. So let's set them up to be successful. This Friday, they're going to have a test on understanding all forms of multiplication, our partial products, both our partial products and our algorithm and expanded form. They're also going to be tested on it in the quarterly test. They're also going to be tested on it at the end of the year on the state test for 4th grade. So the RISE test, our state standard test, that'll be in April. So let's teach them. If they're going to be tested on it multiple times, they need to know it. So there's 3 good reasons why we're going to learn multiplication beyond just the algorithm. So please make sure your students know how to do all 3 ways and not just learn the algorithm. The algorithm is wonderful. It's the most efficient way, but it's not the end goal. Thank you so much.